7-3A. 7-3A.
Did you watch Super Bowl?
Yeah, of course.
Who did you go for?
I was cheering for the Eagles.
There you go.
All right.
The Patriots lost to the Birds. The Patriots beat the Eagles last year.
Well, Bradley Cooper is an Eagles fan, so, you know. All right. Logarithmic expressions. Expressions. All right. These are all going to be done with no calculator today. Yes. You're going to use your brain. Can you believe that? All right. We got two parts. It's pretty short. So here comes the first part. We are going to take an exponential function or an exponential expression. We're going to change it into its log form. Okay, you've never had logs before, and this is brand new to you. So really pay attention. Put your iPad away if you're just playing games or looking at stuff. All right, here we go. It says here, a log. It's a logarithmic expression. We like to just say log, okay? So a log of base b of a positive number x. Of a positive number x. So the log base b of a positive number x is, and this is how we write it. We write log, and they say that the base is b. So the base can be a lot of different things. It can be 10, usually it's 10. It can be base e, it can be base 5, but it's log base b, and it's a little subscript, okay, of a number x is equal to y. So we say the log of x is equal to y if and only if, if and only if b to the y equals x. Okay, and we just spent a couple of days doing exponential functions where it was b to the x equals y. The log is the inverse of an exponential function. It takes x and y and it switches them. So this right here is key. This right here. If you're evaluating the log of a number, you get y. Look at this equation. What is y in this equation? The exponent. So basically, all you need to know is a log is an exponent. Okay? I remember teaching this for the first time. And I remember having this when I was your age in class in Algebra 2, and I was like, what in the world is it? And I just did them. And I got them right, because I just did them. Well, then I finally had to teach it, so I asked my dad, what is a log? And this is what he told me. Just remember, a log is an exponent. So you're trying to find the exponent that works. So what we're going to do is we're just going to practice writing in log form. So we're going to write our exponential equation. We're going to rewrite it so that it's in its log form. Okay? So here we go, letter A. So everyone knows that 25 is equal to 5 squared, right? We know that. Okay. We're going to rewrite this in the log form. It has a log form. So if you look up here, b is the base, x is the number, y is the exponent. Base, y, x. All of these can be written from the exponential form back into its log form. So this is how you write it. Log base 5 of 25 is equal to the exponent, which is 2. Okay? Yeah?
Is 25 an exponent of 5? Or is it just
No.
a regular number?
It's just a regular number. All right, so if you look up here, so b is the base, that's right here, and that number will go here. So if you're writing it, and then the exponent is y, that's the number on this side, and then x is just the number that it's equal to. So if you rewrite all of that, so I like to look at it this way. The base is 5. That's going to go as the base. It's the little number. Okay. 2 is the exponent. A log is an exponent, so it goes on that side. And we're evaluating the log of 25, and that will go right there. Okay. So you're trying to do this first, because then I'm going to ask you to evaluate logs, and you need to know what that means to evaluate a log. All right, let's try another one. Let's do 729 is 3 to the 6th power. 729 is 3 to the 6th power. We're going to take that. That's in its exponential form. See, it has an exponent and everything. We're going to rewrite it in its log form. So I'm going to write the log base 3. The base is what the exponent is sitting on. That's going to be that little number for the log. Log base 3 of 729 is equal to 6. That's it.
Cool.
Okay? That's all you have to do. Letter C. Let's do some harder numbers. It's the same idea though. 2/3 cubed is equal to 8/27. That's a weird 27.
Where's the log at?
All right, so that's the exponential form. We need to rewrite it in its log form, okay? Because we're going to evaluate logs in just a minute. So the log, what's the base here? 2/3, right? Log base 2/3 of 8/27 is equal to 3. So when we're going to evaluate these logs, our answer is going to be the exponent. All right, let's do one more. Last one of these, and then we'll move on to part B.
Are we only doing A and B today?
A and B, yep. 1 equals 7 to the 0. Everyone should agree with that. Anything to the 0 power gives us 1, so 1 equals 7 to the 0. And we're going to rewrite this in its log form. So log, the base is 7.
I almost got it right.
Okay, the base is what the exponent's sitting on. So log base 7 of 1 equals 0. Okay? All right.
What if you wrote
Yeah,
7, 0 equals 1?
that would be wrong.
Okay.
So I'll show you. It's log
So you have to write.
base B of, what did I write? X equals Y. And that will say this. B to the Y equals X. So you have to have them in that right order. Okay? So the base goes to the base. The Y is the exponent. That's your answer. So on. All right, so here we go. Part B. Now, we're going to evaluate logs, no calculator. No calculator. And we're going to do a bunch of these, okay? Until I feel like you got it. So, number 2. Basically, when you evaluate, you're trying to find the exponent. You're asking yourself what exponent will make this true. That's what a log is. A log is the exponent. All right, here we go. You ready to do a bunch? Okay. We're going to evaluate log base 4 of 16. All right, this is brand new. You've never evaluated a log before. So let's think about what this means, okay? What you're actually trying to do is you're taking the base is 4 to what exponent will give me 16?
4. 2 squared.
Squared. The answer would be 2. Okay? So, this is how I set it up. This, I get rid of the log part, because what is a log? It's an exponent. So let's write it over here. I'm trying to find the exponent on the base of 4 that will give me an answer of 16. That's what you're doing. Okay? Let's try another one. Letter B. How about this one? Log base 3 of 27. Now, some of you guys are going to be super quick. Some of you guys have to think about it. So don't just shout out answers, because that really bothers the people who need to think. Yes. And plus my neighbor, he ran into someone who's a student of mine and said, "Oh, Miss Price is your math teacher?" And she said, "Yes, but she talks way too fast. She goes way too fast through the lesson." So I was like, "Oh, I wish that person would have told me that. I didn't know. Tell me to slow down."
Tell your neighbor.
I don't know. He said he didn't remember her name. Okay, so this is what we're doing. 3 is the base. To what exponent gives me 27? Write that down every time. That's going to help you. So when you evaluate a log, you're finding the exponent. And what would that exponent be? 3. Yes. The answer to that is 3. Yes, yes. They'll get harder. All right.
Like 2/3.
Yeah. There's going to be some fun ones. There's some fun ones
Those
coming.
aren't fun.
They're fun. Log base 5 of 5. This one always seems to bother people, but it's actually super easy. Okay, rewrite it in its exponential form. Get rid of the log by writing it as 5 to the what exponent, because that's what I'm looking for, gives me a value of 5. 5's the base. The what exponent, what is that? A 1. 5 to the 1 equals 5. All right, some more.
Are you gonna give us fractions?
Yes, they're coming. Okay, everyone try this one on your own without anyone else's help. Just try it. 2 to the what is 16. Sometimes they're a little bit bigger numbers, or you have to kind of think what times what times what times what.
Do you
16.
think future economics will eventually tell the students that numbers and letters actually mix?
Who? Tell who?
Like kindergartners and first graders.
No, I don't want to scare them. Mm-mm. No. It's funny because it was the letter E week in preschool, and I'm like, oh, E's a number too. And then my son went and told his teacher that, and she said no. All right, 2 to the what is 16. So I don't want to confuse them. 2 to the what? What'd you get? 4. Good. See, evaluating logs, not so bad. Let's do some harder ones now.
Every
Okay.
time somebody says the number 4, I think of that scene in Elf where it's not Santa Claus, and then he's like, howdy, and the kid is like 4.
Oh.
And the elf is like, don't
I think of golf.
do
I think of 4. When my oldest son turned 4, I wanted to have a golf-themed party. He said no. I'm like, you're 4. It was cute. Okay. This is a trick question. Go back to what you originally wrote down at the very top of your page. You wrote down a log base b of a what number? Positive number. Okay?
So now it's not possible.
This is not possible. Exactly. So what you're saying here is 7 to what exponent gives me negative 49? So some of you are like, what about negative 2? What is 7 to the negative 2? 1 over 49. Okay, it's not negative. An exponent won't give you a negative answer at all. So this one has no solution. You can write D and E, does not exist. You can write a circle with a line through it. Don't write 0 though. 0 is not right. Negative 7. Oh, 7's the base. And even negative 7 squared is positive 49. Okay. F. Let's do this one. Log base 5 of 1 over 25. Here are those fractions you were thinking are going to happen. Here they are. This is exciting. Try this one. Try to think about it. Oh. Okay, rewrite it in its exponential form. That's going to help you a lot. When you write 5 is the base to what exponent gives me 1 over 25, that's going to help you a ton. What's the answer? Negative 2.
Woo!
Negative 2, because what happens is whenever you get something to an exponent and it becomes a fraction, you know it's going to drop down. And if it's dropping down, it's moving, it's negative. Yeah, that's why you had to have like all those exponents before. What about this one? Log base 49 of 7. Okay, this is why we did that whole chapter last chapter before we did this one. So you're pretty good with exponents. So when you're evaluating this, you're asking yourself, 49 to the what is 7? And you know that the square root of 49 is 7, but how do we write that as an exponent? 1/2.
Oh, I got it right.
49 to the 1/2 is the same thing as the square root of 49 is 7.
I got it right. I feel smart.
H. Okay, then they're going to do this to you, and it's going to look confusing. They're going to say log 100 or log something, and it's not going to be a base. You know that already?
It's 2.
Yeah, okay. If there's no base, then it's automatically base 10. Base 10, because that's what our number system's based on, 10. There's all kinds of different bases out there. You can do math in base 2 or base 3. It's very confusing, though. All right, base 10. So this would be 10 is our base. To what number gives me 100? And you already said it was 2. 10 squared is 100. So if you don't see a number as a base, then that's what it is. I. Ooh, this one. Log base 6 of 6 squared.
If you just write 36.
You can. There's two ways to do this. One, you can simplify the 6 squared and write 36. Or you can leave it and see if you can solve it that way. Either way, sometimes there's more than one way to get the right answer, right? So this would be 6 to the what equals 6 squared. Well, 6 to something equals 6 squared. Stuff has to equal stuff, right? 2. The answer is 2. Now, if you changed it to 36, you would have done 6 to the what is 36, which is also 2. So we both would have gotten it right. All right. How about
These are a lot of
log base 3, maybe, of 1 over 81. Ooh, this one's tricky. Try this one by yourself. I want to see if you can get it. And then I've got 2 more for you, and then that's it. And we're done for the day. But the last 2 are the hardest 2. I hurt myself. Going down the slide of the jumper on Saturday. I burned skin off of my elbow. It's terrible. But it was worth it. Those jumpers are fun. Nobody puked in it, so that was good. Yeah. Almost. You're in the right track.
I think
3 to the what is 1 over 81. So you know 3 to the 4th is 81, but how do we get this thing to get into a fraction? It would be what? Negative 4. Good. All right, 2 more. And these are the hardest ones. Are you ready? Log base 9 of 27.
Okay.
Okay. These ones are tricky. 9 to the what is 27. Okay, it's not going to be a nice whole number or integer like we've had this whole time. It's going to be a fraction. It's kind of like 2 parts. 1/3, not quite. But you're on the right track. Okay, to get from 9 to 27, what I do is I start with 9 and I go, okay, 9's a perfect square, right? What if I did 9 to the 1/2? If I did 9 to the 1/2, what number would I get? 3. And then how do I get 3 to be 27? You cube it. Now let's put taking 1/2 and 3 together. 3 over 2. Okay, you square root 9.
That's a lot, actually.
You get 3, and then you cube it to get 27. We just did a chapter on those. You're like, what? We have to remember those? So I always take those in 2 parts. I will give you one more of those. No calculator. Log, ew, I don't like that. Log base 8, 16. Okay, try this one. These ones are trickier at the end. So we have 8 to the what is 16. So then I think, okay, what is 8? Is 8 a perfect square? No. It's a perfect cube, though. What if I took 8 and I did the cube root of that? You get 2. And then if I need 2 to get to 16, what exponent would help me get from 2 to 16? 4. Put them together and you get 4/3. You power it to the 4th and you cube root it. It's 4/3.
And then we're done.
And then we're done.